Welcome to Building with Founders, a broadcast by Cast Capital. And in this episode, we sit down with Damian Stefaniuk, the co-founder and CEO of ECCubed, an early-stage startup emerging from MIT, where they're revolutionizing energy storage by integrating a scalable, cost-effective solution into multifunctional concrete. By modifying standard concrete with globally abundant nanocarbon black, ECCubed provides energy storage while maintaining structural integrity. With applications ranging from AI data centers to off-grid housing, ECCubed provides a sustainable, long-lasting alternative to conventional batteries, driving the transition to a renewable energy economy. Hope you enjoy.
What are you building, and why is this the decade to turn cement into a climate tech battery?
In general, ECCubed, we are building electron conductive carbon concrete, which is energy storage solution. So basically, we want our existing infrastructure, like walls, foundations, all infrastructure around us, to not only create our homes and support our infrastructure, but also store energy. And why it is extremely important now, because currently it's expected that 50% of energy basically will grow within the next 25 years. And that is mostly driven by AI data centers. So the energy need is huge. And we want to escape from renewable energy.
Mm-hmm.
But at the same time, when we check how that progresses, we still see fossil fuels present. So we cannot catch up with the demand. So our idea is like, if we cannot catch up with the idea and we want to, maybe we can reduce the demand. So proper energy storage and proper energy management, that's the key to reduce the demand, especially when it comes to renewable energy, because it's like we cannot control wind or solar. Like whenever nature gives you energy, you have to store it and use it when needed.
Yeah.
And then, like, if you want to store it with other energy storage systems, all of them have drawbacks. Like you use scarce minerals all over the world from which are not globally abundant.
Yep.
So that's one problem. Every 10, 15 years, you have to replace, let's say, batteries and so on. Now, those Tesla cars and so on, like, they're great, but every 10, 15 years, when we start disposing hazardous waste and so on, like, that's going to be a challenge. So I think we try to help in that space. Because we just don't see other way around it.
Okay. And how are you guys helping in that space today? Like, how are you guys taking a different approach?
Yeah, so in our approach, we are adding abundant resources, which is carbon black, to concrete. So we basically modify slightly that concrete around you that can basically act as a structural supercapacitor. So basically, supercapacitors, they sound like scientific, but their primary function is the same as batteries, to store electrical energy. But they don't act as batteries based on chemical processes, but it's based simply on ionic charge and double layer effect, which has advantage because...
and now what is that exactly?
It's basically when we create our concrete conductive, we have in our pore space electrolyte, let's say seawater. And then basically when we put non-conductive separator in between, then when let's say we connect our solar panel, you connect to your supercapacitor cell, and then basically ions gonna split to left and both different sides, attract to the nanocarbon space. And then when we disconnect the source, let's say the solar power is gone, then during the night, basically you can reverse that process.
Okay.
So advantage is that there are no atomic intercalations, no chemistry involved, just ions flowing back and forth.
Okay.
Which is advantage because basically it can last for much more than batteries that you have to replace every 10, 15 years. And then in essence, you do not want to build multifunctional structure that basically one of the functionality disappears after 10, 15 years.
Gotcha. And that's the issue we face with for example, the batteries in the Tesla.
Correct.
Where, to your point, the functionality disappears after 15 years. So even though initially it seemed like a great use and advantageous to use that, it depreciates over X amount of time, whereas like what you're working on theoretically won't depreciate in general, or would it depreciate over a longer duration?
Usually over longer duration.
Okay.
Usually batteries face the issue that after 10,000 cycles, 15,000 cycles, they drop the capacitance over, let's say, by 20-30%.
Okay.
And with supercapacitors, when there are no chemical reactions, usually you maintain efficiency for 100,000 cycles, 1 million cycles, 1 million cycles, and you just decrease by a few percent.
Okay. So you said 10,000 to 15,000 cycles compared to 1 million cycles?
Correct.
Oh, wow.
Our tests are mostly run like for more than 100,000 cycles.
Okay.
And we
It's
use
still an order of magnitude
correct,
greater than,
which is a lot.
Yeah.
At the same time, there are, of course, disadvantages, which is energy storage, the energy density that you can store inside.
Got it. And today, what does that energy density look like?
So our energy density for supercapacitor is much, much lower than for batteries. But we started with 20 watt-hour per cubic meter, which is not much.
Okay.
But then
in comparison, relative to a size that I would be familiar with, how does that
that
compare?
would, for batteries, that would be like 10,000 more.
Okay.
Or and so on. It's a kilowatt-hour and so on. But when we are trying, this is early stage technologies. So basically, over time, we can push that forward with optimization of carbon black we are adding. We bumped this number by a factor of 10 to 220. And by mixing procedures and so on, we could further increase by 50%. So it at current, like let's say 1 year ago, the value was around 300 watt-hour per cubic meter. Maybe this number doesn't mean much, but you can imagine the house. So if you imagine off-grid house with solar panels installed on the roof, then basically half of concrete used in that residential house would be enough to meet the daily demand of a residential house. But still, for some applications like data centers, that's still far from what you would expect. So therefore, for the last 1 year, we've been working on optimization of other aspects of this technology. So we've optimized electrolyte inside, and this number further increased to more than 2,000.
Okay.
So now you can imagine, just 10% of your house is enough to, might be enough to power your whole house. And then with this energy demand, when we imagine that 12 billion cubic meters of concrete is cast annually in the world, you can imagine that, even that energy density is low compared to batteries, other technologies, when you can add this kind of small addition to your concrete infrastructure, then the numbers start be meaningful.
Okay. Now I'm curious, how'd you come up with the idea to use the carbon black? And then how'd you guys come up with the idea to alter the electrolytes? Like, could you walk me through the process of
of course,
turning different dials to be able to?
Yeah, that's actually an interesting story, and I cannot take all credit for that. My mentors and first pioneer, my supervisor Franz
like how'd you, even to rewind more, like how'd you come about working on this issue?
That's actually a long story.
We got time.
Yeah. So when I started my PhD, I was working in micromechanics in concrete, like on a nano scale, and I was reading papers and then getting my information, how to test these materials in a micro scale, how to get information about them and so on. So I was reading papers of Professor Franz Joseph Fulm.
Okay.
But at the same time, I didn't know the person at all. And after time, I started collaborating with another professor from University of Houston, Conrad. And then we started collaborating, writing one paper, another paper. He invited me to Houston when I was still in Poland, and to join for a few months as an internship. And I said, yeah, that's a great idea. And then appeared that Conrad was postdoc in Franz group many years before. And then it appeared that all this concrete world, when it comes to nanoscale, it's not that big. So then year by year, I started learning more. I started collaborating in the United States with different groups. And that was the moment in my career when I tried to move forward. And I was actually, I was applying for a position in another university to become assistant professor, but I was rejected. So I said, okay, so what is missing? What I need to improve to move forward? And then I heard about the research at MIT, and I applied, and with recommendations from other collaborators, that's where I got to MIT.
Gotcha.
And that's when I started a journey with this concrete, but multifunctional concrete.
Okay.
And when I joined the project, that was the moment when I knew, okay, this is what I'm really passionate about.
Oh, sure.
Because I can tackle different problems at the same time.
Okay. So what had you interested in working on this problem, and what drew you to MIT specifically?
I think to understand it, I would need to go back even further in my life.
Let's do it.
So I think my father,
Okay.
that was the whole start, because
Yeah. So where are you from?
so originally I'm from Poland,
Okay.
and my grandfather and so on, they lived in difficult times. It was not like you had access to anything. That was a communist time back in the day. So everyone had to work hard and explore different options to provide safety and for the family and so on. So my father traveled a lot abroad.
Okay.
When I was just a few years old, he was a construction worker in Germany, doing some trainings in Greece.
Yeah.
And after a few years of work, he came back to Poland, and then he could afford, and he built a house.
Okay.
And
How old were you at this time?
that time I was 6 years old.
Okay.
So that was the first time when I experienced this kind of construction practices. That time, it's not like you can afford everything.
Yep.
So my father wanted to manage money properly. So him and his uncle and my grandfather, they basically did most of the work while building a house.
Okay.
Because he wanted to save other part of the money, and at the same time gets skills how to build these buildings to start a small construction company, renovation and in this kind of space.
Okay.
So since then, I was basically passionate and seeing how he works on that. Because, when you're a 6-year-old kid, and then, your father, your role model, comes and builds a house where you can, instead of living in a multi-story building, having just small yard, then you start having availability. We had like a forest, lake. You could play around and provide. It also provides a safety. You no longer rent a place.
Yeah.
You have your own space, safe space. That basically was a safe space for me for my whole childhood. So I think.
And you saw him build that from scratch. So like, what effect does that have on you?
I think it's a huge effect on me, that basically seeing some effort, that he's not trying to like work for himself. He's working for family and kids, and I think that affected me a lot.
Okay. All right. So you see your father build this home that allows you and your family to have a sense of security. It's your own place. You have access to nature as well. So as you're progressing throughout your childhood, like, walk me through like what were the next steps to you eventually studying what you did.
Because when you're a kid, you're at school, you don't know what you're gonna follow. So I just try to do my best in different subjects. But it was natural that I meant for science, because I was good at math and physics. I didn't have to study much to get good grades. Use the potential I had, and I saw my father has a company in that space. So I'm like, oh, natural fit will be, I'm gonna go to civil engineering, and then finish my studies and come back and help my father.
Okay. So how were those years working with your dad?
I was joining him during summer.
Okay.
It was a great experience. Again, hard work, because you're going, instead of going to vacation or have fun with friends, you also had to work a bit. But it was in the long run, it was very, very beneficial.
Yeah.
Because you could learn things that you don't learn in school. They don't teach you how to use a drill or basics, how to understand this environment. So that basically, when I reached to college, naturally to civil engineering.
And where'd you go to college?
I was going to Wrocław University of Science Technology.
Okay.
In Poland. that was a huge change in my life, because basically I'm come from smaller city like Piotrków in Poland, where you don't have access to universities. So
And how far is that from Warsaw?
it's like 2.5 hour drive.
Okay.
But it still doesn't give you access when you have to study and so on over the weekends. Then you see your family every few months.
Yeah.
And I think the major change in my life was the end of college.
Okay.
When my goal was to like help my father or go to industry, but I was driven by scientific work a bit as well.
Okay.
So, and I was also inspired by my professors, by my supervisor and co-supervisor in my master thesis about this micro mechanics, which I didn't understand much. So if I don't understand something, that's like, oh, I want to find out.
Okay. Yeah. So how they inspire you, and what did you learning about those micro?
Yeah, then I started realizing that, oh, actually our world that is behind us and how it works, how these structures are basically delivering us homes and the strength, all is basically in that nanoscale, in those molecules, and then later on in chemistry phases. So it's not really what you see, it's basically what you cannot see with your bare eyes.
Yep.
So that was fascinating for me, because then I understood what really matters.
Yeah.
So then I followed a PhD, and
you got your PhD at?
Yes, also at the Wrocław University of Science and Technology.
And now, where do you go from here?
And for a long time, I was wondering what to do, and then there was a moment. Oh, I think maybe I can try to start my career in the United States as an assistant professor.
Okay.
And I applied to multiple places, and I failed.
Okay.
One time after another.
Yeah. How many places did you apply to?
Oh, I think I applied more than 20.
Okay.
And I got maybe 2 interviews, and I sometimes got into the last round.
Yeah.
And I lost. And I think in my life, more than success, what motivates me the most is a failure.
Yeah.
So I don't think I could handle that loss. So I'm like, no, I have to find out what is missing.
Yeah.
So,
and where do you think you get that from?
Again, I think from my father.
Okay.
I think he never gave up. I remembered one time when we were working, trying to work on the house and so on. There was like a Saturday, we work the whole day, then the sun is gone. So I'm like, oh, we're gonna go home.
Wrong.
That was wrong. So that was like my father going and bringing those huge lamps, and then we can proceed. So nothing could stop him.
Okay.
And he's until now like driven and passionate. So I think I didn't want to give up. So I said no. I felt like if I go back to Poland, that would be like, oh, because I didn't get to this system in the United States, so I would feel like a loser.
Yeah, almost like you gave up.
Exactly, and I couldn't do it. I was not able to do that. So I said, okay, like let me take a step back and see what is missing. Okay, I have so many papers, citations, projects, but at the same time, my PhD or my degrees are not from, let's say, ETH Zurich or Imperial College or something like that.
Okay.
Still, those universities, they're great, but still ranking matters. So if the ranking is like 1,000 or hundreds, it's difficult, because then I see like, so who got the position? And I see like, okay, these people have like degrees from these great universities.
And where they go to school?
And they usually, when you go to Stanford, when you go to Imperial College, Berkeley or somewhere, like, it's just a bit easier.
Yeah.
So, and at the same time, so basically that time was the moment when I said, okay, I think in my resume, what is missing is like kind of a big name of a university. So then I said, okay, let me try one more time, apply to MIT.
Okay.
And
how'd you land on MIT in regards of applying?
I think mostly because my collaborators from University of Irvine, Professor Comey and Conrad from University of Houston, and they used to be postdocs at they used to work at MIT.
Okay.
So I kind of had some kind of introduction.
Got it.
So I think that was extremely helpful. So then I could enter interview process and then get on board.
Gotcha.
So I came to MIT and I started working on projects on sustainable concrete. But when I started joining that project about energy storage, no, that was the moment I knew that this is the most fascinating project I have ever worked on.
And how did you stumble upon that project at MIT?
I think there were different aspects. I know that during COVID, there were some kind of changes at MIT.
Okay.
Also, one previous postdoc left because of family issues and so on. So for some time, there was like a gap.
Got it.
And since I got there and I had experience in the lab, and not only, they assigned me to the project and I started to work on it. And since then, basically at the beginning, it was the moment basically like where we didn't have any like energy storing concrete that can light or power your phone or so on. That was the moment where basically it was just on a small 2 millimeter scale.
Okay.
Some graphs showing you that it might work.
Okay.
But
so there was no like MVP at the moment. There was no working prototype to any degree.
No, not at all.
Okay.
And
so how large was the team that you were working on this issue with? And then how'd you guys go from no working prototype to something that could power a phone, or I saw it powering a Game Boy?
Yeah. I think that it was the moment we had these main two professors, and there was another professor from mechanical department on that energy storing part. And then basically I was working as one of I think when I started in the lab assembly, I was the only one working. Then other people, of course, helping. It was a team effort, definitely.
Okay.
But at the beginning, it was like trying to study and see where it is at. But at that point, let me tell you that I did not imagine that this can see the real world anytime soon.
And why is that?
Because when you see like something like for a few years and like still on that 2 millimeter scale, it's a great idea. But sometimes other technologies around your technology have to progress to enable you to push that forward.
So what needed to progress around you to be able to progress what you were doing?
I think there were a few aspects.
Okay.
First, I think people had to come to realization that we have to look for sustainable solutions because we have only one planet, and it's not anytime soon that if we use all resources on this planet,
we can go to Mars yet. It's not on the horizon.
Exactly. So we should be a bit cautious, because with this kind of progress, exponential progress in the world, with these technologies, like we have to be careful about that part. So I think people started caring about these sustainable solutions. It's not only about money. It's also about, what's the CO2 impact? What's the environmental impact? So that allows you to basically think, the industry can change. That was one aspect. Second aspect, I think that need for energy. Since we are working on energy space, basically, as I mentioned, this AI-driven data centers that are they are booming, and the energy demand that is growing. There are just not enough solutions to satisfy the need.
Okay.
So then I think that need from the society is also a driving factor that we can push more. Another is that carbon black industry.
Okay, and what is that?
Carbon is basically like, I see carbon black like watches, like Casio, Rolex, and so on. Both like show you time, but the price, functionality, all of that is different.
Okay.
And this carbon product you can have like in your pencil. Carbon product, you can also have a diamond, right?
This is true.
So if carbon materials, you have the low product ends up, let's say, in your tires. That's how your tire looked like. And but basically the main ingredient there is it's carbon. Just how it's assembled on the molecular structure that determines its functionality, properties, and so on.
Got it.
So that industry started pushing. And in the past, let's say carbon nanotubes, one of the products used to cost $200,000 per ton. So no one would think like, oh, like you cannot use it in concrete industry. Then that price went down to 100,000. Currently, it's around 18,000, and they project. I think that was
what caused that drop.
Technological advancement.
Okay.
Technology, how manufacturing progress, and so on. Also, there are other technologies like they want to produce hydrogen, and one of the methods to produce hydrogen for energy is from sourcing methane and using a reactor to create to produce 1 ton of hydrogen. You produce 3 tons of carbon product as a byproduct.
Okay.
And then that industry was kind of on the research side. But then I attended a conference recently, like maybe last year, and I saw that they started building these reactors like in Australia or something, like large scale. So this is no longer like scientific news. It's this technology as we see it's implemented.
Yeah. Okay.
But then when the technology is evolving, then they realize, like, what are we going to do with that carbon black? So then they start creating reactor to, let's say, not get that kind of cheap product, but maybe enhance its property and then use it in other industries.
To make sure there's no waste.
Correct. So I think there are multiple pieces that allow us to see that this technology has a future and there is enough demand that we can create, rather than a problem, solution to the society.
Okay. All right. So you see the ability for this solution to be something that can be brought into society. When do you start thinking like an entrepreneur and that this could be something that could potentially be commercialized?
Yeah, so that's also a great question, because usually throughout my life, I usually try to work hard, and then usually I get opportunities. And I think it was similar here, because when I started working, in the past, I never planned to come to the United States. I just came here because I got opportunity to get that experience to continue working in Poland. But then one opportunity after another opened me doors. Sometimes one door was closed, another opened. And so when I joined, it was purely scientific thing. Just I wanted to get that kind of additional piece to my resume. But it was combined with passion about the project and a great team at MIT. And then as I was working, basically after half year of work, there was a moment, that was actually a funny story, because that was Friday, I was Cinco de Mayo, beginning of May 2023.
Yeah.
And I was going to work on my electrical scooter, and I got a crash with a bicycle.
Oh.
He came out of nowhere.
Yeah.
And I'm like, this day is not gonna be great.
Yeah. What was the morning?
Yeah, it was morning.
So that guy started early then.
Yeah. I mean, morning, like around 8-9.
Okay. Gotcha.
And then I reached to the lab, and there was a group meeting later on. So I went the day before I started the experiment, and I wanted to check if it works. But that day I did not expect anything out of it. So I basically tried to check. That was the first moment we tried to light LED with this kind of concrete supercapacitor.
Okay.
And then I tried it, and it worked.
Let there be light.
Once again?
I said, let there be light.
Correct. Exactly.
Yeah.
But for a first moment, I'm like, probably I didn't disconnect the source of power, of energy. So I'm like, but I see, no, like it's off. So
what did that feel like?
That felt amazing.
Yeah.
That felt amazing. For a second, I felt like Edison. Like, it's like sometimes like you work hours and you have sometimes in science, it's like you work for months and you have no result. You just discover that this was not possible. So sometimes you can get demotivated.
Yeah.
But with this moment, that was a fascinating moment. And since then, we started seeing, oh, it can work. So then we started pushing the technology forward and then building larger and larger prototypes, power arcade games, start powering your phone, charge these elements with renewable energy, with solar panels going in front of the MIT dome to do so. So it was a lot of fun.
Okay.
But it started right there. And then basically as we progressed year by year, with the support of the whole team, and we started seeing that it can progress much faster than we would have expected.
Okay.
So I think we reached a point that we started seeing, oh, we experienced some problem, we scaled up, and we solved it. So there was multiple problems which we started solving on the run. And I think there was a moment that when I wanted to basically change trajectory of my life, go to either industry or work with another startup, opportunity appeared with this technology that, oh, actually it might be possible to spin off the technology. So that was 1 year ago.
Okay.
That was 1 year ago. And I think in my mind, a lot has changed because in the past, I don't think I had ever thought about it. I thought about joining my father's company and maybe expand it, but I never thought about my own business.
Okay. And then when that opportunity presented itself, what was that decision like? And when did you realize, like, okay, I want to go down this path?
Basically 1 year ago, that was the decision I had to make, whether to go to industry and earn much more or stay and live with my dream. And that was a difficult decision. So I think that was the most difficult decision in my life because I really didn't know what to do. So I called all my best friends, all my advisors from the past to ask what they think I should do. And I don't think they gave me great advices. Some of them said, oh, I would do this. I would go to industry and settle down, or because it's like, I came here to the United States. I want to establish something, but at the same time, I have no one to help me if I don't have family here. Whatever I earn in Poland, it's divided by 4 due to currency and so on. So it's like you work 10 years, you could get an apartment and so on, but you sell it and then you have like quarter of it.
Okay.
So 10 of your years of your work
are
it's like
essentially, okay.
So can you follow your dream? Like, because as I mentioned, in academia, usually money is different than in industry. So many people said like, you're not like 25 years old. I think there's time that you settle down and you can pursue some also private life because, man, you don't have family, you don't have kids. You're 35 years old. Like, what are you dreaming about?
So what had you still wanting and continuing to dream?
I think the quote that my father gave me when I was young, because one time there was a day when my sister got, let's say, I don't remember exactly because I was young, but it was kind of, she got B at school, and my father and my parents were like happy about it and complimenting, and I'm like, why are you complimenting her when I get A minus? Like, you're not happy about it. And then my father took me on the side and he said, no, you can never compare yourself to anyone else. You are one person. You don't compare yourself to your classmates. You don't compare yourself to anyone else. We're going to treat you and we're going to treat your sister based on different aspects. If she's not good in math, but she's good in something else, when she works hard and we see that she works hard and she gets that B with an effort, we're going to give her gratitude. And if I see that you don't work hard and you bring A minus, I'm not going to tell you, oh, you did a great job. No, because you were able to do better. So I think that moment was when I realized that, I should not compare to anyone else. I should not compare myself. Oh, others at my age have career or they have, let's say, families and so on. Everyone should follow their own path, own timeline. And what really brings you happiness. So I think I still wanted to continue and live my dream. And since that 2 years, 3 years at MIT showed me that this has a potential, that was a moment 1 year ago when I started believing in it.
Okay.
In a sense that, oh, I really believe we can do it. And so that's why I said, no, I will not give up. I will try to pursue my dream.
Yeah.
And that's how my journey is at this moment, where I'm still trying to pursue my dream. And I believe that it can really change the world. So I'd rather do that.
Yep.
And see where it goes.
Well, Damian, thank you for taking the time to chat with me today.
The pleasure is all mine, and I'm grateful that you invited me here, Anthony.
No problem.